Hi, I'm Nico. I'm from the STEM 8 cohort, and my presentation will be on the cardboard boat project. In this project, we had to design and create a cardboard boat using a selection of materials. The materials given were 2 sheets of cardboard, duct tape, and an X-Acto knife for cutting the cardboard, and scissors to cut the tape. After creating the boat, which you can see us doing here, we then take it to the Templeton pool and we test if it can get across the pool and how long it will float for. My team of 3 ended up creating a successful boat, which came 4th in the overall tournament. The main question we ran into was how can we efficiently use our cardboard in a way that allows it to have good stability, good speed, and the most floating time. In order to understand stability, you have to look at 2 main factors: the center of gravity, which is the red dot in this diagram, the center of buoyancy, which is the blue dot in this diagram. In the case of the cardboard boat, the center of gravity would be where the person is sitting. So the person operating the boat, the center of gravity would be right in the center of them. The center of buoyancy would be the middle part of the boat that is submerged. To keep the boat upright and not tipping, you have to keep the center of gravity and center of buoyancy in line. As soon as the center of gravity moves in one direction, the water will push in the separate direction on the center of buoyancy, causing the boat to capsize and flip. This is shown in the diagram. One of the best ways to stop this from happening is keeping the hull very flat for our cardboard boats, because it allows for the largest center of buoyancy possible. If you had a circle hull, it would mean that the center of buoyancy was very small, and the slightest movement from the person steering the boat would cause it to flip over very fast. Next, we needed to be able to calculate how much water this boat could displace and how much weight it could hold. First, we need to know that 1 centimeter cubed of water always equals 1 gram. Next, we need to calculate the volume of our boat. So we said that the length of it was 16 centimeters, the width was 3 centimeters, and the height was 6 centimeters. All that together means that the volume of our boat was 288 centimeters cubed. Now we know that 1 centimeter cubed of water is 1 gram, so all we need to do to convert this to grams is take 288 and put it into grams. So it can hold 288 grams of weight at best. I think what I like most about this project is being able to design your project and then going and actually doing it. I think that's a really cool and unique experience that not many people get to do in high school, so I think it was pretty cool.
Nice.
Main thing we learned was, I think, the physics and the science behind how boats float and how they move in water and how they displace water. Before, I just thought that boats just floated. I did kind of took for granted how that worked, and I think that's for a lot of things, that the simplest things look so simple, but they actually have a lot of science behind them. One thing that I want to learn about in the future is not just how boats work, but how the aerodynamics of planes and cars work, how their motors work, and even I could go more in depth with how a larger boat's motor would work. And I hope to see that in the future about kind of going more in depth with kind of vehicles or maybe anything else.